Hello everyone. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Welcome back to the 9th day of the International Virtual Course Combinatorics Perspective 2022. It is an honor for me to see you again in IVC. First, let me introduce myself. My name is Yeva, and I will be a moderator for today's lecture. Today, we will have a special speaker. He is Dr. Sapto Wahyu Indratno from Institut Teknologi Bandung, Indonesia. Let me greet him first. Hello, Dr. Sapto.
Hello. Hello, everyone.
Okay, thank you. Dr. Sapto will give us a lecture about network-based approach for market basket analysis. So, before starting the lecture, let me show you a short curriculum vitae of Dr. Sapto. Okay. Everyone can see my slide, right?
Yes.
Okay. I will read some short curriculum vitae of Dr. Sapto Wahyu Indratno. So, Dr. Sapto Wahyu Indratno is an associate professor at Institut Teknologi Bandung, Indonesia. His research interests are in inverse problems, statistical learning theory, stochastic processes, and actuarial mathematics. Aside from conducting research, he also serves as the head of academic and student affairs for the Common First Year program in ITB, and once become the manager of the student affairs at the Faculty of Mathematics and Natural Sciences, ITB. Based on Scopus, he has published more than 57 papers and hundreds of citations. In 1998, he graduated from Institut Teknologi Bandung for his bachelor degree. And in 2001, he graduated from University of Twente, the Netherlands, for his master degree. And for his PhD degree, he graduated from Kansas State University, United States of America in 2011. These are some selected publications from Dr. Sapto and his co-author. In this year, he published some publications such as optimization in item delivery as risk management, multinomial case using the new method of statistical inference for online decision, and Gaussian process regression using partition sampling model. Last year, he also published some papers. So if you need some information about Dr. Sapto Wahyu Indratno, you can contact him in sapto@math.itb.ac.id. So I will stop share my screen. Dr. Sapto, are you ready to present?
Yes, I'm ready.
Okay, Dr. Sapto, time is yours.
Okay, thank you very much for the nice introduction, Yeva. I will share my, here we go. Can you see the slide?
Yes.
Okay.
The slide is currently in the presentation mode.
Presentation mode.
Yes.
Sorry, that's wrong. Let me share other. Here we go. How about now?
Yes, perfect. Thank you.
Okay. Thank you.
Thank you.
Okay, good afternoon and good morning maybe to all of you. And thank you for coming to this lecture. Okay, today I will give a lecture about application of graph theory in world of retail. Yeah, we call it as market basket analysis problem. Yeah. So the outline of the lecture will be like this. The first, I will give motivation of market basket analysis itself, and then I will introduce some component needed for understanding this market basket analysis, which is frequent set of items or products. And the next, I will give material about classical approach for solving this market basket problem, which is called association rules of products. And at the end, I will finish with the material about application of graph theory in analyzing this market basket. We call it as a graph of product approach. Okay, and let us maybe in between the classical approach and new approach here, I will give a break. Yeah, so we can just break for 10 minutes maybe. Yeah. After that, we continue with this new approach material. Okay, I will give motivation of what the market basket analysis is. Let us start from this illustration. Yeah, I believe that all of you already have experience in doing shopping. Yeah, so if you go into a supermarket, you will see that the layout about where this product should be put is has a different design for each of the store. Yeah, if you try to understand why they put, for example, milk, yeah, in the front part of the store, yeah, there's a reason behind that. In this lecture, I will try to dig information why, for example, a store put the product, yeah, some in the front of the store, some in the middle, and some in the back part of the store. Yeah, so the basic questions when you are going to open, for example, a store, it could be a offline store or online store. Yeah, and this is for example, some questions. You can see that sometimes we want to know, for example, here, yeah, which two or more products are both together, for example. Yeah, because frequently when a consumer come to a store, they buy, for example, more than one items. Yeah, so we want to know what products pair with which product. Yeah, for example, if someone buy milk, and I want to know what's the pair for the milk. Is it diapers or a drink or soda or whatever? Yeah. Other question is, for example, here, yeah, if you want to do the here how to increase the sale. Yeah, so you have to know the strategy where products should be keep in the store, where should not to sell it. Yeah, and this is all the problem that the owner of the store have, and they wants to know how to use the data the transaction data to help them to get profit, for example. Yeah, and also how to decorate the store. Yeah, and how to do cross-selling, how to do upselling, yeah, and so on. So that's the motivation of we need to do analyzing in the transactional data. Okay, so this is the example about what's the meaning of the products. Yeah, in our case, this is just an example. You can see that if you go to store like bookstore or just a food store, yeah. For example, this is just some of items of the store. It could be pen, books, brush, and so on. And what's the meaning of the transaction here is just a collection of items or product in one transaction. Yeah, for example, here, this is for one transaction. It contains pens, books, drink, and bread. Yeah, the other transactions, it could be, for example, here is book, bread, and shirts. Okay, so we want to know what's the pattern of our consumer. Yeah, based on list of this transaction. Okay, that's the idea. Okay, next I will give a simple tools how we can see the situation about the transaction of the items in one store, for example. I will give the definition of the frequent items. This, by definition, is just a set of items that we see many times, yeah, in baskets, yeah, in one transactions. We call it to be a frequency, yeah. And if we informal definitions, I will call it that item is frequency if the number that items contain in transaction is exceed this threshold. Call it here is S as the small s. Yeah. So we call it I is frequent if its support or the number of transaction containing I is greater than or equal to S. Okay. So then based on this, we can see what's the distribution for all of the items that the store has. Yeah. Okay. So this is a simple definition. You can just from the list of transaction you have, you just count how many transactions containing this item set I. Yeah. So the number will be the support of this set I. This is an example of how this threshold small s work. For example, we have 4 transactions. Namely, the first transaction here contains product 1, 3, and 4. The second one contains product 2, 3, and 5. The third contains product 1, 2, 3, and 5. And the last one is just contains 2 items, which is item 2 and 5. Okay. So if we want to know the support of each of these, for example, I'm going to compute the support only for item number 1. Yeah, it's containing only one element here. Yeah, namely, if we focusing on item number 1 from this collection of transaction, we can count there are two transactions in this set of transactional data here. So we call it the support of set 1 is 2. Yeah, we do the same thing for item number 2, number 3, 4, and 5. Okay, if you look at this, the smallest support will be at this item number 4. Yeah, because it appears only in one transaction here. Okay, if we use the threshold, yeah, we want to use the small s equals 1, then the frequent item will be only item 1, 2, 3, and 5. Okay, so 4 is eliminated from the list because it is less than the threshold that we use here. Okay, and if we are going to create the frequent item with 2 elements, then we can just create from this frequent item. For example, we can just list all possibility of the pairs of the items. For example, here I wrote 1, 2, 1, 3, 1, 5, 2, 3, 2, 5, and 3, 5. So they are the possibility items which contains 2 products. Okay, and then using the same way, we can compute the support for each of these item sets. For example, here 1, 2. If you see 1, 2 here only contains in this the third transaction, so the support is 1. Okay, and for the second item set 1, 3, we have here and here, so we have 2 as the support of the item set 1, 3. Yeah, similarly for 1, 5, 2, 3, 2, 5, and 3, 5. Again, if we use the same threshold for the support, at the end we only have 4 of the frequent item with support 1, which is we can see 1, 3 is in the set, yeah, 2, 3, and 2, 5, and also 3, 5 is the frequent item with support 1. Okay, if we want to know what's the frequent item set with element which has 3 elements, we can just do the list. Yeah, let us find all possibility from this frequent item set to make a set with 3 elements. If we do this, we will obtain only 2 possibilities, which is 1, 2, 3, 2, 3, 5, and that's all. Okay, do the same thing to count the support. We just look at this transaction data here. 1, 2, 3 only contains in this 1, 2 in the third transaction, and 1, 2, 3. Sorry, it should be 1. Yeah, it should be 1. So yeah, 1, 2, 3 should be 1, and 2, 3, 5 should be 2. So this I did the wrong thing here. It should be the other row. Yeah, so 2, 3, 5 should be 2, and 1, 2, 3 should be 1. Using the same threshold here, then the last item set that we obtain is only one item set with 3 elements, which is 2, 3, and 5. Okay, so we cannot make item set with 4 elements because this is the last frequent element that we have. Okay, so that's one is an example on how we construct frequent item set from this transactional data. Okay. All right. So the main goal for the market basket analysis is to find patterns, yeah, in the collection of sale transactional data. Yeah, you can imagine if you have a big mall or store, maybe you will have maybe 100,000 transactional data, yeah, per day, for example. Yeah, you can imagine how large the data that you are dealing with. Yeah, and then you want to see the patterns between the products from the sale. Yeah, and if you succeed to find the pattern, then you can see how to use the pattern to do the upselling or cross-selling, yeah, to get the bigger profit. Okay, so that's the goal of the market basket analysis. Yeah, the key words is that we want to see this pattern from a collection of transactional data. Okay, now let us go to the classical approach for doing this analysis. Yeah. So the classical approach is a method to construct this type of graph. It's a directed graph, yeah, based on conditional probability. So here the tool is probability theory, yeah, but in calculating this conditional probability, we can just use the based on the number of data satisfying these conditions. Yeah, I will show later the example of how we can compute this conditional probability. Yeah, so the idea is from the transactional data, we have a collection of item set A, yeah, and item set B, for example, and we want to know the probability that if you buy item set A, then you also will buy item set B, for example. Okay, so the idea is to find if the probability is large, for example, then you are sure that if someone buy A, then also this guy will also buy B. Yeah, but if the probability is small, then if you buy A, then with small probability that you will also buy B. That's the idea of calculating the conditional probability here. Yeah, and at the end, we can just connect all the item set by this directed edges here. Yeah. Okay. And see, and then we analyzing the meaning of the number here, right? Okay. And also at the end, I will show you the result of, there's an example later, shows that we can show the graph with, for example, here, item set A has a larger radius, yes, compared to item set B. That's based on the support of this item set A. So it means if this is bigger, the circle of item set A is bigger than item set B, it means that the support of this item set A is bigger than the support of the item set B. Okay, and for the edges, you can see later that if this, for example, has dark color, it means that the probability that A connected to B is higher than if you have a lighter color here. Yeah. So that's how we visualize the connection between products. Okay. Okay. So in having this type of graph, you can see whether or not you can do the cross-selling, for example. Yeah, if you see that, for example, there's high probability to get B to C, yeah, and you know that if someone buy A, then this guy also will buy B, and you also know that if someone buy B, we also buy C. Then for cross-selling, you can also introduce this product to someone who buy this item set A, for example. Yeah, if you have this age and this age have high values of probability, then if someone buy A, you can also introduce this new item C to this guy. So that's the name of cross-selling words. Okay. Okay. Now let us discuss about the classical approach. This classical approach in the literature is famous, called by this association rules. Yeah. Associations mean that you want to derive the association between each of the products. Yeah, how strong that this product A connect to this product B, for example. Yeah. So the tools is just like I mentioned. The tool is how we can compute this conditional probability. Okay. Before we go into deep, I will give some definition and notation so that you can understand the material easily. Okay, so these rules, were introduced by this guy called Agarwal, and the goal is to extract the frequent sets, and we want to present the frequent set with the graph, with the like causality relationship. For example, here I use if you buy I, then is it possible that you also will buy J, for example? So we want to know the probability that this event happen. Yeah. So the form of the association rule will be denoted by this I with a right arrow to this set J. Yeah. So on the left side could be a collection of items, but on the right side is only one item. Yeah, so that's the rule of this association rule. Next, I will give how we can compute this conditional probability that I mentioned in the introduction. Okay, let us see. Here we go. So in this material, the probability, the conditional probability will be also called by confidence. Yeah, it means that how confident that if you buy I, then you also will buy J, for example. Yeah, how confident is that this event will happen. Yeah, so how we compute this, we can just calculate it. The number of transactions containing I and J divided by the total number of transactions. Yeah, so T here means that this is transaction, yeah, containing I and J. Yeah, and the absolute notation means we compute the number of this type of transaction. Okay, so this is simple. You can just find from your data set, yeah, which transactions fulfill this condition, and then divide by the whole transaction. Yeah, it's very simple. So what's the meaning of this? Just like I said before, if this is close to 1, it means that we have high confidence that if you buy I, capital I, you also will buy this item J. Yeah. So if you compute this to all of combination in your product based on the transactions, you can arrange and sort this from the highest one to the lowest one, and you can see the pair of item set and an item which has this highest confidence, for example. From there you can do a planning for selling this pair of I and J. Okay, so here you can see that based on this formula, we can see that if, yeah, this is the notion of probability. If item set I has no influence on J, then computing this is similar to computing the only transaction containing J over the whole transaction. So we do not need the information about the item set I because I has no influence on J. Okay, so computing the conditional distribution here is similar to just computing this probability just the item J. Yeah, we do not need any information from this item set I. Yeah, if I has no influence. Okay. Next, I will define some notations about the rule itself. So in the literatures, you will see that some of them use this notation to gather all the information. For example, here I use the notation of R, T, capital T, and small s and small c. Yeah? So it means that this is collection of rules satisfying, for example, the minimum support is S and the minimum confidence is C. Yeah, applied to set of transaction capital T. Yeah, so this is just a collection of rules satisfying the condition of S and C. Yeah, from your data set. Okay, this is the definition that I used before. The T with input A means that the set of transaction, yeah, containing this product I. A, sorry. Okay, next I will give a simple example how one computes the confidence and see what we can tell about the products. Yeah, for example, I will use the same problem. It's like in previous, we have 4 transactions. We want to know the association between this item set 2 and 5 with this product J equals 3. Okay, is it I want to know whether or not this will give high confidence, for example. Yeah. So I will just compute how many transactions containing this 2, 5, and 3 from this transactional data. You can see 2, 5, and 3 contains in 2, 5, and 3 here and here. Right? You have only 2 transactions from this transactional data. And the total of the transaction containing this I, yeah, is just 2, 5, 2, 5 here, 2, 5 there, and this you only have 3, yeah, out of 4. Okay. So if we compute the confidence of I to J, then you can just divide these 2 by this 3. So you have 2/3. Yeah, it is yeah, close to 1. Yeah, this is large enough to say that you are confident that if someone buy these 2 products, 2 and 5, will also buy the product number 3. Okay, so if someone in your store buying these 2 products, then you can just introduce product number 3 to this guy. Hopefully that this guy will buy product number 3 too. Okay, so you are doing the cross selling in retail business. Okay. So that's the idea of computing this confidence. Okay, here I use the visualization of our graph because let's see the support of I to 5 is 1, 2, 3, and the support of j equals 3 is 1, 2, 3, then I just have these two nodes as have the same size of radius, yeah. Okay, and I also have these lines is little bit darker, yeah, dark blue, because it is close to 1. Okay. Okay. Yeah. And then I will recall that if I wrote like this, R, T, S, and C, it means that collections of rules, yeah, namely A to B, which satisfies these two conditions. Yeah. So the support should be greater or equal to S%, and the confidence should be greater or equal to C%. Okay, so that's the meaning of the set RTSC. Okay, the problem with these conditions, you might have some not useful rules, for example. So rules mean like this, yeah. This is one of example of the rules. If people buy 2, 5, then they will buy 3. That's one of element of rules. Yeah. So you can imagine from this transaction, you can have many combination of rules. Yeah. For example, if you buy 1, then you will buy 5. So 1, 5, 1, 3, 1, 4, and so on. Yeah, you can do all the combination between the item sets and an item. Okay, it could be many rules. Yeah, and some of them could be not useful. Yeah, but some of them could be very important. Yeah, so we need to find not useful rules, so that in doing this analyzing the data, you will not waste your time, yeah, by working on this unuseful rules. Okay, so some of methods to reduce uninteresting rules you can use, for example, the definition of interest here. This is just the confidence minus this Tj over number of T. Yeah. So you can use this to see whether the rule is interesting or not. Okay. So you can see that if I has no influence, then just like I showed before, the first term will be equal to the second term. Therefore, the interest of this I to j is 0. Okay. And what's the meaning if the difference is positive? You can see here that the meaning is that if I present in a basket, it will cause the presence of the item J, for example. Yeah, but if it's negative, you have the other wrong meaning. Yeah, I discourage the presence of J. Okay, so then if this happens negative, if the negative value of this interest happen, then you should not sell this I if you want to introduce this item J, for example. Yeah, don't introduce I if you want to introduce the item J, for example. Okay. Okay, let us go to the next method, how to reduce these uninteresting rules. The next one is, call it lift. Yeah, this is just a ratio between this joint distributions with the if we assume that A and B are independent, for example. Yeah, so how to compute this? We can just approximate this computation by computing the transaction containing A and B divided by number of transactions containing A times number of transactions containing B, for example. Okay. So if it's close to 1, for example, then A has no influence to B, for example. Yeah, A and B are independent. Yeah. So if people buy A, then this guy will, you cannot say whether or not this guy will buy B, for example. Yeah, because A and B are independent. Okay, but if this leaf is greater than 1, it means that the number of transactions of this, yeah, is bigger compared to independent assumption. So it means that it is possible that A and B bought together, yeah, in the one transaction. Okay. But if it's less than 1, yeah, it means that most of the time A and B bought in separate transaction. Okay. Okay, now I want to ask you to do some exercise. Yeah, I will give this after you follow the materials. I want you to work with me. Yeah. Okay, I will give, this is the example of transaction. For example, we have 6 transactions, where the first transaction, it means that this transaction contain watermelon, banana, orange, and mango. But the second one, it only contain watermelon, orange, and mango. Yeah, and so now I will ask you to work together. Yeah, and I want you to answer this one. Can you tell me what's the support of watermelon? And can you compute the confidence of this rule? And also leave of this rule. Is it interesting or not? Yeah, is it confidence or not for this rule? Okay. Yeah, So please, if I want to ask you all to solve this problem. Yeah, I will give time to do the calculation. So the problem is this: we have 6 transactions, and I want to see whether these rules, for example here, yeah, this rule is interesting or not, or this rule is confidence or not. Okay. Can anyone here help me? Can you tell me what's the support of watermelon? Yeah, some of you answer with 4. Yeah, that's correct. Yeah, support of watermelons is 4. Yeah, you can count from this. This is the first transaction containing watermelon. This is the second one. This is the third one. This is the fourth one. So you have 4 transactions, which is the support of the watermelon. Okay. Now the second question: what is the confidence of this rule? Some of you says that 2/3. Anyone else? Two-thirds. Watermelon and banana. Yes. So here, watermelon, banana, orange. You have to compute how many transactions containing watermelon, banana, and orange. Let us look at this. Here, the first transaction containing watermelon, banana, orange. What else? The 5th transaction, yeah, this guy, watermelon, banana, and orange. So you have 2 out of 6. Okay, and then you divide it by watermelon and banana, yeah. So 1, 2, 3. So 3 out of 6. So you will get 2/3. Correct. Yeah. Thank you. And the last question is, how about the leaf? Watermelon, orange to mango. Watermelon, orange to mango. What's the leaf? leaf is this. Anyone? One over 8. 1 over 8. Let us check. So watermelons, orange, and mango. So you compute how many transactions containing watermelon, orange, and mango. Okay, this is the first one. And this one is the second one. And what else? This is the third one. Yeah, the third one. So there are 3. And let us compute how many transactions containing here is item sets A, and how many transactions containing the product B. Okay, so item set watermelon and orange will be this transaction, the first one, the second one, and the fifth one. So there are 3. Yeah? And containing just mango, 1, 2, 3, 4, 5. Correct? So what's the result? You have this is 3. This guy is 3. And this guy is 5. So we have 1 over 5, right? Rian, can you tell me how you got 1 over 8?
I see 2 rows that contains watermelon, banana, and mango together, and divided by the number of rows contain watermelon times the number of rows contains orange.
Oh, yeah. Oh, sorry. I think you confused with A and B here.
Yes.
Yeah. Because A here is not just watermelon. Yeah.
Yeah.
It's on this row. A is watermelon and orange, right?
Oh yes, I'm confused.
Okay.
I'm sorry, Dr. Sapto, for interrupting your
Yes.
lecture. Do you actually want to use like a pointer or writing something? Because sometimes I don't see your pointer. So
Yeah, sorry.
I feel confused. This represents what and so on.
Okay. I don't know how to use the pointer here. Let me check. Can I? There is a pointer up and just pen, yeah. Can you see the pen pointer?
Not yet.
Like this?
Yeah.
Okay.
Red line, right?
Yes, correct.
Yeah, I can see it.
Yeah. So
Okay.
what I said before,
Okay, thank you.
You have to know that the rules always that the B here is just only one item or one product. Yeah, one item. But for this side, it could be collection of items. It could be a set. Yeah, a set. Okay. Right. Then was the question was that this one is A, right? And this one is B. Okay. So how to compute transaction containing A means that the transaction should contain watermelon and orange, correct? Therefore, we have watermelon and orange that contains in this one. What else? This one. What else? This one. Correct? Yeah. So the number of transactions containing A, sorry, I should write like this. This should be 3, right? And the number of transactions containing mango is this one, this one, this one, this one, and this one. So there are 5, yeah, containing B. Okay. And transaction containing these 3 items, watermelon, orange, and mango, you only have this one, and this one. 3, yeah. A and B. This is 3. So then at the end we have this is just 3 over 3 times 5. These 3 cancel, and then you have 1 over 5. Okay. Oops, sorry. This is 1 over 5. This is 2/3. This is 4. Yeah. Any question about these computations? Oops. Okay. If there is no question, I will continue to one example. Oops. Okay. Okay. Here I give an example how we apply association rule to groceries data. So this I took the data from GitHub. Yeah, you can just Google it and you will find this data for free. Yeah, so it contains 9,835 transactions. So it's quite big. Yeah. Then from this, I will get the support of each of the products. Yeah. For example, the highest support is at this whole milk product. Yeah, and it's only contain, I think, 20 products here from 169 products. Yeah. Okay, so you can see that the highest support is at this whole milk product. Okay, so here's the first information that you can dig from the data. Yeah, the support of each items, and then you can also apply the rules. Yeah, for example, here I use the rules of S equal 0.001 and C equals 0.8. Yeah, to the groceries data data set, and you will see if you show the, for example, some of the rules, you can see this result. Yeah, from the result you can compute the support, the confidence, the leave, yeah, and how many transactions containing this rule. Okay, and if you order these rules based on the confidence, so the highest confidence for the transaction is 1, so it means it's very confident. So from this you can see if people buy rice, sugar, and these people also will buy the whole milk. Okay, yeah, so yeah, from this you can see that if people buy this rice and sugar, you can promote a whole milk to this guy. Yeah, because based on the data, the people who bought rice and sugar will also buy the whole milk. Okay, or you can just put on the store, for example, the place of rice and sugar, and beside that you put the whole milk. Yeah, you can put the whole milk beside this rice and sugar, in the hope that if this guy buy this product, rice and sugar, this guy also will buy the whole milk. Okay, so that's the type of cross-selling. Yeah. The same thing for this products. Yeah, atom set. Okay. Okay, there's a question. The intersection here means just not the intersection, but union, maybe. Yeah. Sorry. So transaction containing watermelon, orange, and mango. Okay. Is it 3? I don't know. Let me check. Yeah. Sorry, there's some question. Watermelons, orange, and mango. How many? This is the first one. This is the second one, and this one, the third one. Yes, 3. Yeah. So I wrote this 3, right? Correct. Okay, let us continue the grocery example. Okay, yeah, you can order the rules based on, for example, here I apply the order based on confidence. but you might also try to order these rules based on supports or based on leaf. Yeah. From this, we also see that the rules is interesting because it's greater than 1. Yeah, the leaf is greater than 1, 3.9. And you can explore this information. It could be 1,000 or 100 rules that you gain from this threshold. Yeah, but maybe some of them is not useful. Yeah, but try to extract the useful one, right? Okay, why the support is not integer? Because I divide by the whole number of transaction. Yeah, because sometimes we need to know the percentage, not the number. Sometimes we call it 100 and the other is 3, but we don't know is 100 is big enough or not. So we just compare the number to the whole transaction to see how big this support belongs to an item or items. Okay. Yeah, because if not, if it just number, we don't know whether this is already big enough or still small. Yeah. Okay, let us continue. Let's see. Okay, so from these results, you can visualize, yeah, all the rules, yeah, but the rules that satisfying this threshold, yeah. So you can see that the rules that I show here all satisfy this conditions. Yeah, for example, here the support is bigger than 0.001 and the confidence also bigger than 0.8. Yeah. Okay. Same thing to this one. Okay. How the visualization of the rules? You can, here I use R to show the visualization of these rules. Yeah. Here the color is based on the color. You can see that it's not too strong. Yeah. For example, here leaf. Here the darker if you have a darker color, it means you have very strong leaf. For example, here. Yeah. But most of these notes have a very light color, so it's not too strong number of the value of leaf. Yeah. For the radius, it's if you support. Yeah. The bigger circles means you have a bigger support for the products. Yeah. For example, here whole milk has, I think, the biggest one. Yeah, the biggest radius of the note here. Yeah, but the color is not too dark. Yeah, it's very light color. Yeah, and the age also is not too, it's not clear enough. Yeah, it means that there is the connection maybe is not too strong. Yeah, but from this you can see the map of the association rules. Yeah, that if someone, for example, here buy liquor and glass wine, they also will buy bottled beer, for example. Yeah, this is very strong leaf. Yeah. Okay. And you can see other relation here. Yeah. Then you also can do this cross-selling, yeah, and decorating your store, for example, which one we have to put in the same place, for example, yeah, so that the people will buy item A and also will buy item B, yeah, based on this relation. Okay. Okay, but yeah, just like I mentioned before, the limitation of association rules, it depends on the S, yeah, the support, and the parameter confidency. Yeah. Okay. It also can produce many rules, and then you have to see one by one. Yeah, if it's thousands of rules, but not all of them are useful, for example. Then how to filter out this the most, for example, interesting rules, for example, yeah, that also is not obvious. Yeah, and many of course the rules sometimes repeated from the existence. Yeah, so they are redundant rules appear. Yeah, and yeah, it's sensitive. Yeah, I will just include that. It's too sensitive model. Yeah, this is model which is too sensitive because it's based on the parameter S and the parameter C. If you change the parameter, it will change the whole rules that you have. Okay. Of course, it will change the decisions, yeah, in arranging the items in your store, for example. Okay. Okay. Okay, this is the last material for the first part. So just like I said in the introduction, I will give a break, yeah, maybe 10 minutes, yeah, before I continue with the next approach, which is roughly speaking a new approach, yeah. So we try to create associations which is not based on directed graph, but just regular graph. Yeah. Okay, that's all for the first part. We will continue in 10 minutes, yeah, to get into this new materials. Okay, I will give the times to Eva.
Okay, thank you, Dr. Sapto. Dear participants, so we will have a break about 10 minutes. Maybe we will start again in 2:32. Okay, we will have a break. Thank you, Dr. Sapto.
Established in 1920 with the name Technische Hogeschool te Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia. The 3rd of July 2020 is marked as Institut Teknologi Bandung's 1 century existence. The establishment of this long-established institution is recorded in history as the founding of Indonesian technical higher education and the pioneer in the advancement of science and technology in Indonesia. Located in Bandung, West Java, Indonesia, precisely on Ganesha Street number 10, ITB currently has 12 faculties, 29 undergraduate programs, 52 master's programs, 26 doctoral programs, and 2 professional programs. Other than the campus site located in Ganesha, ITB's campuses are also located in Jatinangor and Cirebon. 39 programs have been internationally accredited from accreditation boards around the world, namely from the United States of America, ASEAN, Germany, Japan, the United Kingdom, South Korea, and the number of accredited programs is expected to increase in the near future. ITB has been developing its cutting-edge research through the 102 research groups from 12 faculties and schools, 24 centers, 7 research centers, and 5 centers of excellence. To date, ITB has also established 104 startups, 315 intellectual property rights, and 137 innovations. In the spirit of In Harmonia Progressio, ITB alumni have worked and excelled in various fields and sectors. For instance, Insinyur Soekarno as the first President of the Republic of Indonesia, B.J. Habibie as the third President, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Fakultas Matematika dan Ilmu Pengetahuan Alam Institut Teknologi Bandung atau disingkat FMIPA ITB merupakan fakultas yang menyediakan program studi berakreditasi unggul dan terbaik di Indonesia bagi mereka yang ingin mendalami pengetahuan di bidang kimia, fisika, astronomi, dan matematika. FMIPA ITB merupakan yang tertua dan terdepan di Indonesia di bidang matematika dan ilmu pengetahuan alam dengan reputasi yang sudah diakui secara nasional dan internasional. Sebanyak 20 program studi yang ditawarkan terakreditasi A atau unggul oleh Badan Akreditasi Nasional Perguruan Tinggi. Dan keempat program studi di tingkat sarjana mendapatkan akreditasi bergengsi secara internasional. Setiap tahun, FMIPA ITB mendidik lebih dari 2.300 siswa, baik di tingkat sarjana, S2 maupun S3. Dalam memberikan pengajaran berkualitas, dosen-dosen FMIPA ITB didukung oleh 16 kelompok keilmuan yang aktif melakukan berbagai penelitian. Kelompok keilmuan astronomi bertujuan untuk mengembangkan ilmu astronomi, astrofisika, ilmu luar angkasa, dan ilmu lain yang berhubungan dengan astronomi. 6 kelompok keilmuan fisika aktif melakukan riset tentang bumi dan sistem kompleksnya, tentang material-material yang ada di alam dan pemanfaatannya, tentang material magnet dan fotonik serta pengembangannya, dan banyak lagi lainnya. Di bidang kimia, 4 kelompok keilmuan secara produktif mencari temuan-temuan baru untuk pengembangan, penerapan, dan penyebarluasan ilmu kimia, serta penyelesaian berbagai masalah yang berkaitan dengan kimia di masyarakat. Begitu juga dengan 5 kelompok keilmuan matematika, di mana para dosen di dalamnya mendukung proses pembelajaran matematika, serta pengembangan dan penerapan matematika di dunia modern saat ini melalui penelitian mereka. Proses pembelajaran dan kegiatan riset di FMIPA ITB didukung oleh fasilitas-fasilitas mumpuni yang dimiliki oleh fakultas. Observatorium Boscha merupakan observatorium modern tertua di Indonesia dan Asia Tenggara, sehingga memiliki peran yang sangat penting di dunia dalam pengamatan dan eksplorasi benda-benda angkasa. Laboratorium Fisika Terpadu dan Laboratorium Kimia Terpadu di FMIPA ITB memungkinkan para peneliti dari kelompok keilmuan yang berbeda-beda untuk dapat mengakses berbagai peralatan penelitian di satu lokasi saja, yaitu di masing-masing laboratorium terpadu tersebut. FMIPA ITB memiliki deretan kontribusi nyata dalam memajukan ilmu pengetahuan yang dinikmati oleh mahasiswa, masyarakat, dan juga industri. Bagi mahasiswa, komitmen FMIPA ITB dalam mendukung mahasiswa memaksimalkan kompetensi ternyatakan melalui upaya untuk secara rutin mengirimkan mahasiswa ke ajang kompetisi internasional yang sangat bergengsi seperti Olimpiade Matematika.
FMIPA ITB memfasilitasi mahasiswa FMIPA untuk berkompetisi pada tingkat nasional maupun internasional. Fasilitas yang disediakan berupa pembinaan dan akomodasi yang meliputi biaya maupun tempat pelaksanaan. Pada tahun 2021, FMIPA mengirimkan 5 mahasiswa pada kompetisi matematika internasional IMC 2021 dan berhasil mendapatkan 2 emas, 2 perak, dan 1 honorable mention.
Bagi masyarakat, lewat kelompok-kelompok keilmuan, dosen dan staf FMIPA ITB giat menjalankan pengabdian masyarakat yang sangat membanggakan fakultas.
Observatorium Boscha bersama dengan program studi dan kelompok keahlian astronomi di FMIPA ITB mengupayakan agar konsep-konsep dasar sains yang berkenaan dengan astronomi itu dapat menjadi bagian dari hidup masyarakat yang terintegrasi. Observatorium Boscha dengan dukungan FMIPA bekerja sama dengan banyak pihak, bisa NGO, bisa industri, bisa korporasi. Jadi ada banyak yang bekerja sama mendukung program pendidikan astronomi yang menyediakan sumber belajar yang tidak ada batasnya. Karena peran Observatorium Boscha dan astronomi di ITB di bawah FMIPA ini ada banyak sekali yang berhubungan langsung dengan masyarakat. Umpamanya saja pengamatan bulan baru, hilal, bagaimana hari-hari penting itu ditentukan, banyak sekali kontribusi dari Observatorium Boscha.
Kami telah banyak kerjasama dengan berbagai instansi pemerintah pusat dan daerah, pihak swasta dan industri di dalam maupun luar negeri untuk memajukan pendidikan, penelitian, dan pengabdian masyarakat. Kita telah juga membuka layanan penggunaan alat lab bagi masyarakat luas, diantaranya SEM, Microcity, NMR, alat praktikum pengajaran, dan HPC yang ada di gedung BSCA, dan juga peralatan lain yang tersebar di gedung Prodi dan juga Observatorium Boscha. Dengan peralatan ini, kami telah memberikan pelayanan dalam bidang pendidikan, penelitian, dan industri. Kerjasama dalam bidang penyelenggaraan beasiswa pasca sarjana juga telah kita lakukan, diantaranya penyelenggaraan pendidikan S2 pengajaran bagi guru di Departemen Agama dan juga Provinsi Bangka Belitung, dan akan menyusul beberapa Pemda lainnya. S2 dalam bidang aktuaria untuk staf BPJS Ketenagakerjaan dan pendidikan S2 Master by Research dan Doktor by Research di lingkungan organisasi penelitian BRIN. Pendidikan S3 bagi staf Kementerian Perdagangan, dan lainnya. Kami juga sangat concern dalam upaya membantu meningkatkan kualitas pendidikan menengah dan dasar yang diramu dalam program peningkatan kompetensi guru dan siswa, memberikan pelatihan bagi para laboran atau teknisi, penyiapan bahan ajar, modul praktikum, dan lainnya. Kami siap bekerja sama.
Sementara kiprah FMIPA ITB bagi industri hadir dalam bentuk kinerja riset dan inovasinya.
Pada saat awal pandemi COVID-19, kami kemudian diminta oleh BPPT BRIN untuk mengembangkan alat uji cepat deteksi antibodi COVID-19. Nah, kami bersama-sama peneliti di FMIPA, kemudian SCTH, dan juga mitra industri kami, PT Pakar Biomedika Indonesia, didukung oleh BPPT BRIN dan juga tentu saja FMIPA, kami mengembangkan alat uji cepat untuk deteksi antibodi COVID-19. Alat yang dihasilkan dinamakan e-COVID-19, saat ini sudah tervalidasi dari FK Unpad dan kami sedang melakukan pengajuan izin edar.
Okay, dear participant, because it is already 3:33, 2:33, so we will continue our lecture for the next session. So, Dr. Sapto, time is yours.
Okay, I will continue. Let me open. Let me share. Okay, let us go to this material. Here I will give another view how to do a market basket analysis based on graph partition. Yeah, I will explain later how to give another method where we can try to construct the transactional data to namely undirected graph, for example. Once we obtain this undirected graph, we will do some partition to this graph, and based on the partition we can analyzing the relations between product for each partition. That's the idea of this graph approach. Okay, so the concept itself, introduced by this Netes and Netes v. Kaula. Okay, so the idea is, just I mentioned before, from the transactional data, we try to construct, namely a product network, which is a graph, yeah, and then find the partitions of this graph. And the partition, we will call it as community. Yeah. So we group the products that represented by a graph, and then we can do the analyzing based on the relations or connection between the products in one community, for example. So the big picture will be like this. This is the transactional data. And then from this transactional data, we construct undirected graph, like here. So the node will be product. Yeah. So different from the classical approach. Yeah, we have here is undirected graph. From the classical approach, we have directed graph, right? Okay. From this, we try to partition this graph into communities, for example, like this picture. After we obtain communities, we can do the analyzing based on what you call it. For example, we can apply the centrality measure to find which product that is more important and which product which is can influence the other products, for example. Yeah. So by doing these partitions, it's easy for us to do the market basket analysis for each of the community. Yeah. So let us go to this topic. So I will take you to do this how to create this product graph. Yeah. So here the vertex itself will be the product that we offer. Yeah. And the age will be the relationship between the products. Okay, for example, here I give visualization that this is the whole milk and also the canned fish here. Yeah, so these two products is connected by an age. It means that these two products belongs to, for example, some transactions. Yeah, it could be only one transaction or more than one transaction. Yeah, and the age will be the number of transactions containing these two products. Yeah, so it will be weighted undirected graph. Okay. Okay, let us do the construction, for example. This is the simple example. Suppose we have three transactions. Here there are four products, P1, P2, P3, and P4. And one means that these products appear in this transaction, and 0 means that the product is not in this transaction. Okay, so here we can see that the first transaction contains product 1, 2, and 4. The second transaction contains product 1, 3, and 4. And the last one only contains product 1 and 3. Based on this transactional data, we can create namely weighted adjacency matrix, for example, here. So P1 and P1 we just put 0 for all the diagonal here. But if we see that the number of transactions contains product 1 and product 2, based on this, we can count this one only. Yeah, so we put one transaction here. Yeah, so the number of transactions containing P1 and P3, it will be P1 and P3, it will be 2, this one and this one. So I wrote 2 here. And the same thing for this P1 and P4, we have 2 transactions. Yeah. Do the same things to all of these elements. We will get the matrix of this weighted adjacency matrix. Okay. From this, we can create a graph. Yeah. Weighted undirected graph. Yeah, based on this matrix. Yeah. Here P1 and P3. P1 and P3 is connected by one edge with weight 2. P1 and P2 with weight 1. P1 and P4 with weight 2, and P3, P4 with weight 1, and the last one is P2 and P4 with weight 1. So this the way that we create the product graph. So we call this as a product graph. Yeah, which is connect each of the product with other product. Okay. So once we created this product graph, the next step is we partition the graph. Okay. So the next step will be how we partition the product graph. Okay. The tools to do this is we introduce the communities, yeah, which is a collection of tightly connected nodes. Yeah. So, for example, this is the illustrations. So it's we assume that this graph has, for example, here 3 communities where each of the communities contains tightly connected products. Yeah, for example, here. Okay. Okay, so here I wrote that what's the contributions of these communities. Yeah, so the contribution is, yeah, we want to know which products goes together frequently in the transactions, okay, in the market baskets. Okay. And also it's easily to analyze because maybe we have less nodes here compared if we do the analyzing for the whole networks, yeah, for the whole nodes. Yeah. Okay. So how we detect these communities? We will use the notion of modularity. Okay, so we can measure the communities by computing the modularity of these communities. So next step is I will introduce this formula, how to say that the communities has been detected. Yeah. So here modularity, a tool for measuring, yeah, how well a graph is already partitioned to communities. Yeah. So the idea is just suppose we have C capital communities, and each of communities we compute the number of age within the group, within the community C, and minus the expected number of age within the group C. Yeah. So this one is based on the data, based on the graph itself. But here, this is based on if the ages are created randomly. So this is the expected number and the conditions that the ages connect to two products randomly. So if it's 0, it means that the connection in the group is connected randomly because this and this guy is equal. Yeah. What we want that the difference is positive. Yeah. So we have to maximize the difference between the real connection here based on the graph and the connections based on randomly connected connection. Okay. And here I use notation, common notation. G is for graph. The absolute of V means the number of vertex. E absolute of is the number of edges. Yeah, and from the graph theory, we have that the total of degree of each node, yeah, is equal to 2 times the number of edges. Yeah, so this is a common result. Yeah. Okay, so this is an example. We have graph with vertices, and the number of vertices equal to 6, and the number of edges equal to 7. Yeah. So the degree for each of the nodes is listed in this table. Okay. So if you sum this degree, you will get 2 times the number of edges. Yeah, just like what we have here. Okay, we will use this in deriving the formula for this modularity. Okay. Okay, here this is the notation and tools needed for deriving the formula. So here, just like before, Ki and Kj are a degree of node I and j respectively, and Ij is the number of edges between node I and j. So you can have multiple edges, yeah, between two nodes. Yeah. And this one is the probability that node I to connect to node j, yeah, is based on the degree of node j divided by the total degree of the graph, which is 2m. Yeah. Similarly, j to connect to I, which probability ki divided by 2m. Okay, tightly means that tightly here means that mostly that it's not in one community connected to each other. Yeah, the ideal communities that we have a complete graph, for example, that's tightly in this concept. Yeah, maybe we can measure the tightness with the density of the graph, the communities. Yeah, there's a question about the tightly here. Okay, so let us continue to this definition. So here, the probability that an edge happen to connect I and j then equals to this, because this is just a randomly connect. Yeah, so you can just multiply the probability of this, yeah, I to connect to j and j to connect I, because they are randomly connect. So you just multiply these two probability, and because we have undirected graph, so you multiply by 2, because there are 2 possibility from I to j or j to I. Okay, so there are 2 possibility to connect an edge to these 2 nodes I and j. Okay, so we add the 2 probabilities. Okay, and then the expectation of an ij, because we have the whole the graph itself has m edges, so it look like binomial distributions with m edge, and the probability of an edge connects to two product is equal to this. Then based on the binomial distributions characters, the expectation of the random variable Nij is equal to the number of edge, the number of edges times the probability of the edge happen to connect between these two nodes I and J. So that's the result came from binomial distributions. So we can simplify this into Ki times Kj over 2n. Okay. So let us plug this into the notion of this modularity formula. So this is the weighted undirected graph adjacency matrix minus the expected connection, number of edge connect to node I and J, which is written as this, just like I show here. And then you can see that here, because we compute to all the communities, so sum over all the communities here. So suppose we have this capital C communities, and this is the nodes in the community. For example, I and J in the same community. We sum up all these difference, and this can be written as this, and the delta function is just a Kronecker function. So this is equal to 1 if we are in the same community, and 0 if I and J are different community. Okay, so what's the meaning of Q is positive? So you have this is what we want, because it means that the matrix, adjacency matrix here is far away from randomly connected, because this one is bigger than this one. So less than 0 means this assortative mixing, and Q equals 0 means they are randomly connected. This is what we want to avoid, this less than 0 and equals 0. So what we want is we want to maximize this Q, so it should be a positive number. Okay, so the idea is we want to find what you call it, a combination of community which give this the highest, the positive highest number. Okay. Okay, so that's the goal. We want to maximizing the modularity. But in practice, usually we use this rule. If we get Q is greater than 0.3, this is already good enough to say that the community that we constructed from this maximizations is already satisfied the tightness that we mentioned before. Okay, let us do, for example, here I will give what happened if we combine one community into other communities. What gain that we have if we combine one community into other communities? We can measure the gain that we obtain using the following formula. Yeah. Delta Q Ci to Cj means that the gain that we obtain if we move, if we combine community I into community J. Yeah, it can be computed easily using this formula. So here, M is the number of edges of the graph, yeah, and the ij is here I define as shared degree of communities I and J. The I itself is degree of community I. Degree of community I is just the total number of degree of the nodes in community I, for example. Yeah, so all degree in this community we sum out to get the I, for example. Yeah, dj is the degree of community J, and M is the number of edges. Yeah, so I give an example here. Suppose here, okay, suppose we have these three communities. Yeah, we know the degree of each node here, yeah? Based on this graph. Okay, now the goal is we want to combine C1 and C2. So yeah, here I want to combine this community to this one, for example. Yeah. Okay. Now how to do this one? First, I have to compute shared degree between these two communities. Yeah, you can see that these two communities connected by these two edges. Yeah, 3, 5 and 4, 5. Okay, let me change to the value. Yeah, so here we have two shared edges between these two communities. Okay, so let us compute the D21. Yeah, so based on this definition, is number, yeah, sorry, this should be the number, the total shared degree of communities I with communities J. Yeah, so if we see, we have two edges. Yes. For this we have here we have 2. Yeah, degree from this node 5 shared to this community 1, and from this community 1 you have degree 1 from this 3 and degree 1 from this 4. Yeah, so in total you have 2 from the 5, 1 from the 3, and 1 from the 4. So you have 4. Okay. Okay, maybe I should write that here. Yeah. So here M, can you count how many edges for this whole connection? What is M in this case? 16. Okay, I believe you. 16. Okay. So I calculated the 1 before is 4, right? 2 plus 2 is from 5, 1 from 3, and 1 from 4. So this is just 4. Okay. D1 is the degree of community 1. So you just total all the degree for each of these nodes. So can you compute what's the total degree in this community? For example, 1 is 1, 2, 3, 2 is 1, 2, 3, 3 is 1, 2, 3, 4 is 3. Sorry, 3 is 4, right? 3 is 4, 4 is 4. So 4 plus 4 plus 3 plus 3. 8 plus 6. 14, yeah? 14. Okay, thank you. 14, correct? Okay, how about D2, the total degree in this community? 10? Okay. 10 or 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, yeah? 11, sorry. 11. Okay. Now let us plug this into this formula. 1 over 32, right? 4 minus 14 times 11. 11 over m is 16. Can you help me? What's the value of this? Anyone? What's the number? Minus, what is that? Minus what is? Minus 0? Okay, minus 0.17. All right, thank you. All right, okay, so if I combine C2 into C1, the gain is negative 0.17, so it's negative. Yeah, I want a positive gain. Yeah, in this case, I want you to do this exercise. If you combine C2 and C3, what is D23? D23 is 2. Okay. D2 was 11. How about D3? 37. Okay. How about the gain? Negative 0.08. Thank you. Oh, okay, 87. Thank you. Okay, I want to ask you, which one is better? Combining C2 with C1 or C2 with C3? Okay, great. Yeah, because we have 0.087 is greater than it was negative 0.7. Okay. Then we prefer to combine this community to this one, right? Yeah, if we compare with this one. Okay. Yeah. But in application, we always find positive gain. Yeah, if you still have negative, so it's better to stay in this 3 communities. So this is already good enough. Yeah, we cannot combine this to this because the gain is negative. If we combine this to this also, we only have negative gain. Therefore, we stop. Yeah, we stop with this stage that we only have 3 communities for this type of graph. Okay, so the algorithm to detect these communities, first at the start, start from make all the nodes be communities. So at the first step, you have, for example, here 11 communities. Yes, so you have 11 communities, and then use the same concept. You try to combine, for example, community 1 and 2. Yeah, and compute the gain. Yeah, and then because 1 is connect to 3, you also try to combine these 2 community 3 and also to this guy. Yeah, and find the largest positive gain. Okay, suppose the largest one is 2 here. You can compute with this formula. Yeah, this is just example. Suppose this is the largest one, then you combine this 1 and 2. Okay, right, and then do the same step at the same way. Yeah, you want to combine this new community to community 3 because you have age here. Yes, shared age, and also you have new community shared edge with community 4, and then you try to find the gain, whether or not to connect this new community to community 4 or to community 3, and choose the higher positive gain. Yeah, and suppose it is like this, and at the end it could be in one community. Yes, and then from this you do the same. Is it worth it to combine this new community to community 5, and so on and so on? Yeah, and at the end you will get these 3 communities. Okay, so that's the basic idea how we detect communities in a graph, yeah, using the modularity concept. Okay, next, after we obtain communities, then what we do next? Yeah, of course, we are able to analyze the community. Yeah, you have tools to do this. Yes, this is from the previous lecture by Ibu Rino Pia. You already learned about between the centrality and degree centrality, but here degree centrality I will do this relative to the total edges, yeah, in the same reason with the support, yeah, because if you have degree 4, how do you know that 4 is big enough? Yeah, therefore I compare with the whole degree, yeah, which is 2 times the number of edge. Okay, so you can apply these 2 measures, and this already discussed in Ibu Rinovia lectures, and I will just use it, yeah, without explaining this measure to detail. But the idea is between the centrality means that if this is this node or this product has high the large value of between the centrality, then it means that if someone buy this product, this guy also will buy this one, yeah, because this is the central of the transaction. Yeah, suppose this is the transactions. Yeah, this is the first transactions, and this is the second one. Transaction always contains this important product. Yes, so you can see which ones is always exists in transaction. Okay, degree of centrality is to measure the which one is the most important. Yeah, which product which is the most important. Yeah, it has the highest degree. For example, here, yeah, you have 1, 2, 3, 4, 5, 6 degree, and compared to the other product, so this guy is the most important product, yeah, in the community, for example. Okay. Okay, this is example I use the same data, which is groceries data from the previous example. You can see here the statistics of the data. Yeah, I also mentioned before. So the highest support is in this whole milk. Yes, and you can also see the distribution of the number of items in one transaction. Yeah, so for example, here's one. If the transaction contain only one product, it has 2,159 transactions. Yeah, until if transaction contain 32 products, it's only one transaction. Yeah, you can see. Sorry, from this. Yeah, from this information, you can see what is the highest number of items in one transaction, for example. Okay. This information says that which one is the highest support. Yeah, this is top 5. Yeah, top 5 of the highest frequent items. Yeah. All right. Okay, let us see the look of the product graph. Yeah. So it has how many items? Okay, there are 169 products here. Yes. And there are 9,835 transactions. Okay. If we construct the product graph of these groceries, you will see this. Yeah, it's very crowded. Yeah. Okay. Then, if we try to analyze this type of association, it is very difficult. Yeah, because it's too many edges connected to the nodes. Yeah. Therefore, the idea is how to make this crowded connection into communities. So by partition this graph, it make us easy to analyze the association of the product itself. Okay. So if we apply the modularity detection, we get the following results. Yes. Here we use the threshold of this number. So we only want to know products that are both alone, which is greater or equal to 50 times. Yeah, using this threshold, we obtain here there are 6 communities. Yeah, and each communities they have different number of products. Yeah, so range from 7 to about 50 or 47 here. Okay, so let us see what the community looks like. Okay, so here's the first community. You can see we only have 7 products. Yeah, 7 products. So the connections is not too crowded. Yeah, but based on the modularity formula, this is can be categorized as community. Yeah. So from these communities, we can apply the measure. For example, here we use page range, which is the degree centrality. Yeah, you can see the highest one is this guy. Sorry, napkins. Yeah. So this is the highest degree of centrality in this community is napkins. Yeah. So we have so in this community, you can say that most of the product can be bought together. Yeah. So most of the time, for example, here, soft cheese and light bulbs, they are both in one transaction. Yeah. Okay, so this is for the first community. The second community is more crowded than community one. So there are 47 products here. Yeah. So here I computed the bitwitness centrality. Yeah. So the highest one is for this community, we have frozen chicken. Yeah. So based on the community, is mostly maybe frozen food here. Yeah. Okay. We have the information that frozen chicken is the important product. Yeah. That mostly the transaction contains this frozen chicken. Okay. And the second one is toilet paper. Yeah. For the third one, yeah, less dense than community 2. Here I show the page range, the degree of centrality of this community. Yeah. So the highest one for the third community is this one. Sorry, this guy. Yeah. Rolls and buns. I think there's a bread, type of bread. Yeah. Okay. Beside this, you can also apply the association rule, yeah, to this communities. So we have more information compared to the classical one. Yeah. So we have specific communities, but for the classical one, we assume we only have one community. But here we have more detailed character for each of these products belongs to. Yeah. Okay. The fourth one is contains more products, yeah, than the first and the third. Here I computed the bitwitness centrality. Yeah. So here the highest one is frozen chicken. Oh, it's the same as before. Yeah. So what is, yeah, the same. So okay, so let's see. This, yeah, this frozen chicken appear twice here. Okay, I will check. Yeah, it should be only show once in only one community. Yeah, but it should twice but I will check it later. Yeah, there's something wrong here. Okay, and the fifth commodity, we have degree of centrality. Here I got tropical fruit, the highest degree of centrality, and so on, up to commodity 6. Here you have the calcifer is the highest between centrality. You can see from the classical approach, whole milk is the popular one, but here whole milk is not so popular in this commodity. It means that the contribution of the whole milk is not so large compared to like salad dressing or decalcifer or mustard. Okay, I think that's all the material that I want to share with you guys, and hopefully if this will also help you, for example, in the future, to do research in retail, for example, in business, in retail, you can apply this because it's still new, still in progress. You can do some development. We can apply social network analysis tools, in exploring the association of each product. Okay, that's all. Thank you. And if you have questions, you are welcome. I will give the time to Eva.
Okay, thank you, Dr. Sapto, for your inspiring talk. It is interesting actually to study some mathematical concepts behind the market real-life problems nowadays. And I'm sure that we obtain a lot of new insights about how powerful a network is, like a network that can represent the meaningful relationships in large transaction database and help us to analyze the communities in the network. So any comments or questions from participants? You can unmute your mic or write in the chat box. Okay.
I have a question for Mr. Sapto. In Community 6, I see that the table contains only 4 products, but in the graph there are many points. Why the table are only 4 products?
Okay, so I choose only the 4 highest products, because if I write all of these products, it contains 47 products, so it's not fit on the slide.
Thank you, sir.
Okay. But in fact, you have all the information. You can look at all of the products, but for this lecture, I just take maybe top 5, or top 4 to make it not, because it's not so difference between what you call it, after the 5th product, the number of centralities between the centralities is not difference much. I just cut it into top 4. That's all.
One more question, sir.
Yes.
If we have found the products that have the highest degree of centrality, are the products can be offered in cross-selling?
Oh, okay. So the degree of centrality means that it connects to many products, right? Okay. So you might also apply this cross-selling technique, yeah. If someone, for example, if product A connected to C, D, E, F, G, H, for example, yeah. If someone bought product H, you might promote this product A, yeah, which is the product with highest degree of centrality. Okay.
Thank you, sir.
Okay, any questions or comments again from another participants? I think that today's lectures will be useful for someone who wants to open business market, right?
Yeah.
Can
Yeah,
I ask one question, Dr.
Yes.
Sapto? Is it possible to consider another real life problems using the parameter that you explained before? Maybe
Yeah.
in news or something else?
Of course, as long as you can construct this graph, yeah, this is usually applied to social network, yeah, because you can connect one person to other person by this social media, right? So you can easily connect one person to other. As long as, for example, you have news, then how to connect one news to the other news? You have to know how. For the products, I explained that it's possible to connect one product to other product by means of transaction. Okay, in one transaction, you can see whether or not one product is bought together with the other product. So that's tools how to connect these two products. As long as you have method to connect to news, then it is possible to apply this to the news problem.
Okay, thank you, Dr. Sapto. Actually, there is a question in chat box. Muhammad Ridwan, would you like to unmute or not? Would you like to unmute your microphone to ask directly? Or?
Okay, about the dynamic graph, yeah. Okay, yeah, for this problem, actually, we analyzing the data set in the offline approach. So we just gather the data, for example, weekly data, and then you apply this method. Yeah, but what Ridwan asked here is, how about if the data is keep coming? Yeah, the data is keep coming. So can we do it in online way? So this is open problem with one. You can start now, maybe before someone else do this. Yeah. So if the data, because the online shopping style is, you cannot stop them from buying anytime, right? So should we generate the partitions every 5 minutes? I don't know, but it's possible. Yeah, you can just store the data first for 5 minutes and then you update the partitions. Yeah. or every 1 minute, whatever you like. Yeah, as long as your computer can handle this. Okay.
Okay, is there any more questions? Is there any question? I see in the chat box there is comments. Thank you so much, Prof. Okay.
Oh, you're welcome.
From Mubdas Fatima, yeah. Okay, okay. I think because all of the question in the chat box and question by directly have been answered during the lecture. Maybe every participant understand clearly the lecture. So please give a big applause for our speaker, Dr. Sapto Wahyu Indratno.
Thank you very much.
Okay, before we end this lecture today, we will have a photo sessions. So to all participants, please open your camera and don't forget to smile during the photo session. Mr. Faisal will help me to capture some photos of you. So Mr. Faisal, please, you can count from now.
Yes, everyone. We have 4 slides here. I will start to screenshot from slide 1. Okay, ready? 1, 2, 3. Okay, we move to the slide. 1, 2, 3. And the third slide. 1, 2, 3. And the last one. 1, 2, 3. Okay, thank you very much.
Okay, I think this is the end of the lecture today. And I would like to thank to Dr. Sapto, thank to all of the committees, especially Pak Faisal, Bu Brita, and Pak Rudi, and to all of the participants for all of your attention. We remind you that there is a class in the evening, maybe for the next 3 hours from now. The lecture will be delivered by Professor Ilyas Kotsirias. So don't forget to join again the lecture for this evening. So see you again. Bye-bye and thank you.
Thank you very much.